Okay, so this one and the next one are really nice problems. I say nice, but they're not friendly. So first thing we're going to do, we can factor out the bottom, and then we're going to use like a little bit of a trick. We're going to go, oops, we're going to go limit as x approaches 0. Let me make sure I'm recording. Yes, I am. Of sine 3x over x 5x squared minus 4. Okay, so far so good. Now, the trick is usually when you have this x down here, you kind of leave it down here, but being mathematicians, we know that we can write it like this as follows. We have the limit as x approaches 0, and we're going to write this as sine 3x over x, and then 5x squared minus 4. Now, that's a good thing because, first of all, if we plug 0 into the bottom, it's not really a problem anymore because now that's going to equal negative 4, but it's going to be a problem up here on the top. But we did learn something in one of the videos, and it said that we can kind of multiply by 1. And so what we're going to do is we're going to sneakily, I say sneaky, 3 over 3. Okay, we're going to multiply by that. And so what we have here is the limit as x approaches 0 of 3 sine 3x over 3x. I'm going to put that in parentheses. Over 5x squared minus 4. Okay. Now we can take this limit because we know this thing approaches 1 because we have that rule from earlier. So when we take the limit, we now have this is equal to 3 times 1 over 5 times 0 minus 4, which is equal to negative 3 over 4. And let me make sure that's the right answer. Let me find it. This is 2.4. I'm pulling it up on my computer. Just give me one sec. I think that's right, though. If it's not, we're going to be sad. All right, 2.4. Where are you? 2.6, 2.4. This is number 35. No, 43. Let me make sure. Yeah, 43. Negative 3/4. Okay, so we're good on that one. And then you asked for number 49, which is the following. So we're going to do, I know that was really tricky, and it kind of sucked. We have limit x approaches 0 of 1 minus tan x over sine x minus cos x. Okay, so this I had to work this out a couple times because it's kind of tricky, but here we go. I might get lost, but we'll see. We have limit as x approaches 0 of 1 minus, well, tangent is sine over cosine, sine x, cos x, over sine x minus cos x. So far, so good. And then what we're going to do is we're going to get a common denominator in the numerator. This is equal to limit as x approaches 0 of cos x. I'm going to write this as this minus sine x, and then all over cos x sine x minus cos x. Okay, so far so, oh, I'm putting 0. This isn't 0. Sorry, this should be x approaches pi over 4. I forgot, if it's 0, that makes this really easy. This should have been a pi over 4, I'm sorry. If it was 0, it'd be over because sine 0 is 0 and cos 0 is 1. Or, yeah, is 1, so you could actually just plug it in. Okay. So from here, let's I guess this is an x, not a y. We can keep, change, flip, I guess. So what that means is multiply by the reciprocal limit. X approaches pi over 4. And then we've got our cos x minus sine x over cos x times, and then this is over 1. Keep this the same, change this to multiply, flip that over. We have 1. And then we've got sine x minus cos x. Okay. And then from here we can go, okay, well this is just the limit as x approaches pi over 4. We can factor out a negative from either here or up here, and we'll get it to be the other one. So let's do that. We have cos x minus sine x over cos x, and then we have times cos x minus sine x over 1. Okay, and now we do our famous cancel cancel move. And so now we have is equal to the limit as x approaches pi over 4 of, this is going to be, this is a 1 now, this is a 1, negative 1, so negative 1 over cos x. Okay, and then we can actually evaluate this now. This is going to equal pi over, no, yeah, pi over 2. So we're going to, or no, I'm sorry, pi over 4 is equal to the square root of 2 over 2. And so this is going to be negative 1 over square root of 2 over 2. Okay, and then how can we do this? This is going to equal negative, okay, so keep this, this is 1 over 1, change the sign, so negative, and then flip that, 2 over square root 2, I hope, yeah, okay, and then this is going, we don't need this anymore, and then this is going to equal, if we want to rationalize the denominator, because that's what they did in the book, times the square root of 2, this is now equal to negative 1 times 2 square root 2 over square root of 4, which is equal to negative 1 times 2 square root 2 over 2. And so cancel, cancel, this is equal to negative square root 2. And that's your final answer. That's the one they have in the book, and that is how you go about this problem. These two were nice problems, not to solve, but they're nice problems because they force you to try a couple things. And I don't blame you for this being difficult. I don't want you to feel discouraged. These are very complex, and sometimes I get stuck on these kind of things. And that's why it took a little bit to get this video up for you. So I hope that this helps. I hope that you see all the stuff going on here and all the little tricks. If you ever have like a sine 3x or something, you always want to try to make that into a sine 3x over 3x if you can, at any way possible. So thank you for watching.